There are a number of mitigation principles that we use to make our systems easier to secure. So the first of these is defense in depth. What defense in depth means is that a small breach of a system shouldn't become a large one. So if a user gets access to your corporate network, right, so they've come into your business, they've gotten onto your corporate network, you're going to still want to have internal checks within the applications in your company to make sure that that user has access to the resources that they're trying to get access to. So for instance, if I come in as a visitor to your company and I'm on your network, I want to make sure that my financial system is protected, that I ask for more credentials before I give access to that data. So defense in depth is all about adding these additional security checks within our systems. An extension of this is to vary the mechanism that we're using for security. So if you have the same username and password pair that's used for all accesses to your internal systems, that can be a huge problem if a user just finds a post-it note with a username and password written on it. Because even though you're going to be asked for that user and password multiple times, you have it once, you'll have it again. Right? So varying your security mechanisms is also important to make your security systems much more robust in practice. There are several obvious downsides of defense in depth, though. The first is complexity. Right? By implementing multiple layers of security within our system, you've had to implement multiple layers of security, so there's just more code for you to write and more systems for you to maintain. These systems are also less usable. As a user, you might just want to get onto a corporate network and be able to access all of the systems within your workplace. Right? So this can be frustrating. The next principle we want to consider is least privilege. What this means is that a user should have the minimum security credentials that they actually need to perform their jobs. We don't all need root access all the time. Usually, a normal end-user account is sufficient. And in a corporate environment where we have many different layers of security and types of information that we're trying to protect, it is important that we really think hard about what types of access each user should have. This is important to protect both against malicious access, where an attacker is gaining access that they shouldn't otherwise have, but also for accidental access. For instance, so an employee can't see their coworkers' performance reviews. So what we want to do when we're implementing least privilege is to add finer grained access controls within our system. And this starts by having a strong set of security policies in the first place. What are the levels that we want to have within our security, within our user tree, and what types of roles and access should each of those users have? And keeping track of all of these different roles and responsibilities will increase the complexity of our systems. So while there is a great amount of benefit from implementing a least privilege access mechanism, there are also costs associated with it. The next mitigation principle is separation of duties. And what separation of duties seeks to do is make it so that we authenticate important and impactful tasks. Now, this is good for protecting against bad actors, but it's also really helpful for avoiding impactful accidents. So what we want to do is we want to make sure that before a user can perform some really delicate task that's hard to roll out or cancel from, that they get validation from another person. Right? So you can think of this from the Cold War when you have a missile launch silo. One guy can't run in there and turn a key and launch the missiles. You need two people to turn the key simultaneously, and those keys are far enough apart that one person can't reach both of them at the same time. And this is adding that same principle into our own systems. When we think about how we implement separation of duties, what we want to do is identify what those key impactful tasks are and add process so that they cannot be completed without getting some type of authorization. So for instance, if you're at a company that is selling a product, you want to make sure that before you authorize any sale over $1 million, you for instance get sign-off from at least one other person. And maybe you'll have another threshold that's $50 million and you need to get sign-off from somebody who's at least 1 or 2 levels above you in the organizational hierarchy. One downside to implementing a separation of duties mitigation strategy is that it can impact the velocity of your organization. If you don't carefully consider the types of tasks that require additional authorization versus a more run-of-the-mill task, you can really slow people down by having them always waiting to get authorization from their fellow peers or from their supervisors. So we want to think really hard about the types of tasks that we're really trying to protect with this type of strategy. Strong authentication principles say we should use enhanced approaches for verifying the users who are accessing our system. Passwords are notoriously weak in this way. If I just write my username and password down on a post-it and give it to my friend, they can log in as me. And if they go and lose the post-it, then someone else can also log in as me. Passwords are a weak form of authentication because they only require a user to know something to gain access to a system. Most strong authentication approaches are instead multi-factor authentication schemes. So these require that you know something and have something. So for instance, you still need to know your username and password, but you might also have to have your phone or some other type of secure piece of hardware to gain access to the system. So only by knowing something and having something can you gain access. Multi-factor authentication is useful because it means an attacker needs more than just your password to gain access to your system. Of course, this also adds complexity to your system because you need both your password and this additional authentication mechanism. The principle of non-repudiation means that system users should be held accountable for their actions. From the point of view of an attack, non-repudiation is really helpful because it means you can track how the attacker moved through your system and what data they accessed. But for your legitimate users, non-repudiation is also useful so that they know, the legitimate users know, they should not be trying to access data that they are not allowed to have access to. The main mechanism used to provide non-repudiation within our system is through auditing. And the way that we're going to do this is through auditing with some kind of atomic logging mechanism, where we can only add elements to a log immediately, but they can never be removed. Of course, that has its own security risks as well, because then those log files themselves become valuable resources that we also want to protect. There are a diversity of surfaces that can be attacked in modern systems, so it's often helpful to think about security from a layered perspective. Google has a really nice white paper on this topic where they split the security and how they think about security for their systems into these 6 key operational layers. The first is hardware infrastructure. Inside Google's data centers, they know all of the server and networking equipment that they run, and they verify it to make sure it meets their security standards. Next, they think really hard about service deployment. All of their services can only talk with other predefined services using explicit communication channels. And in this way, they can make sure that there aren't unexpected interactions between different services. Next, we have user identity. At Google, all employees have to use multi-factor authentication, and their users are only allowed access to the specific services that they work with on a day-to-day basis. Then we have secure storage. All storage within Google is encrypted using a rotating set of encryption keys. In terms of internet communication, all network traffic that goes between Google's data center and the public goes through something called the Google front end, which ensures that this traffic has perfect forward security applied to it. And finally, we have operational security. And this means that the Google engineers employ safe coding practices when they're writing their software. All code is reviewed, and they think about the security of that code when it's written. Google also spends a lot of time working with open source projects, the ones that they use internally, to make sure that those systems are also up to date in terms of the security patches they have applied to them. These layers are a great example that show how the mitigation principles we previously described can be applied in practice. So in terms of defense in depth, by thinking about these 6 layers, Google isn't relying solely on border security to make sure their networks are secure. Right? They're checking the hardware, the services, identity, storage. They're checking all of these different features throughout the tech stack. In terms of least privilege, the employees within Google also have very fine-grained access control, so they can't go and access the data for the whole corporation from one workstation or as one individual user. In terms of strong authentication, the users also have to use 2-factor authentication, and that's required within Google's infrastructure. And finally, in terms of non-repudiation, the infrastructure that they use has a strong logging component built into it, so they can really keep track of who's accessing what service from where, so they can track unusual entries and unusual accesses within the system, but also to ensure that internal actors aren't accessing data they aren't supposed to be able to.